In this new tutorial we are going to see how the G-code application works, which allows us to use a ctrlX as a numerical control. The goals of the tutorial is to know how to configure the system, how to create and generate numerical control programs, as well as the use of M functions. The version used in this case is ctrlX Works 2.4 and it allows us to use the current system package. Apps and license required. In this image, you can see the applications and license required to control the system. License for Motion, license for the G-code application, license for the node-RED, license for PLC, functional package for the PLC template, list of license with their reference number. Optionally, license can be installed for the 3D visualization and the oscilloscope. Please note that this manual has been made with the existing elements at the moment, and therefore something may vary since it is a product in constant evolution. Configuration of profiles, access and kinematics. From the ctrlX Works EU application, we will have to configure the access following the usual way. Next, the profile of the real axis must be defined. In the example, in order not to confuse the issue of names, the initial indicates with BF have been used, although this is just a suggestion. The names assigned in general may vary depending on the names read by the system itself. The minimum structure for the system to work properly should include these parameters in both the AT part and the MTD master data telegram part. The next step is to create the axis and assign the created profiles. In the example, we see the configuration of the X-axis. The same should be done for the Y and Z-axis. In the Limits menu, we can assign the movement values. This should be done on all axes. You could also modify the units of the values, although they should not be touched at first. Modification to these values must always be validated with the Save button. For the use of G-code, we also need to create a kinematic for motion control. To do this, we will have to access the coordinate motion option and add a new kinematic. For the example, we will select the Cartesian option. The selection of kinematics will only be validated if we have the corresponding license. On each of the axes of the kinematics, we will assign the axis created previously. Package G-code for Coaches PLC. To operate from the PLC part, we will have to download the files. ctrlX Automation, G-code UI 2.4.0 or ctrlX Automation G-code UIE 2.6.9.3. This package contains two parts. One, on the one hand, the template for the PLC, and on the other hand, the template with the necessary flows for the node-RED. Here you can see the files included in version 2.4, and in this other image the version of 2.6. And here you have the link to download the commented files. The first step will be the installation of the PLC template, and this must be done from the Tools, Add on Installer option within the PLC Engineering. Once inside, select the package to install. Template installation process. In order for the template to be installed correctly, the ctrlX Works software must be stopped. Once finished, you should see that the template is installed. Next, the templates must be activated, G-code and the kinematics interface and axis interface part. The insertion of the templates generates a whole series of folders, modules and tasks in the PLC system that we can see in the following image. Insert JSON file for not read. For the operation of the system, the not-read package must be installed, which includes the control flows for the use of the system as a numerical control. There are two ways to upload the JSON file. The first method from the Manage App Data option. The second is to import the JSON file from not-read flow editor. In my case, I use the first one. First of all, we change the system from operating to setup. Select Manage App Data and access the archive option from where you can select the file to upload. Be very careful when uploading if we had already uploaded the file and made modifications, since in this case we will reload the original configuration. The loading of the JSON file interdicts the flows for the control of the G-code application, and it also allows us to access the system control screen. Dashboard. From the dashboard option of the not-read tab, we can access the main configuration screen from which we have access to the main control option of the system. First of all, we will have to define which kinematic we are going to work on. To do this, we will access the configuration screen, which is accessible from 2 points. On the one hand, from the main button located at the top of the screen, and the other from the lower option buttons. In the second option, a warning message always appears indicating that we should stop the axis and reset the errors in case of selection another kinematics. In any case, once the kinematic selection screen, we must choose the desired kinematic that will be validated when activating operating button. In this part of the main screen, we have the machine program created, their selection and their treatment. Location of the name for a new program. We can enter the name of a new machine program and validate it with the created option. This lists the program you have created. With this button, we can refresh the list of programs. With this one, as we have said, the program is created with the name that we have set in file name to create it. And with this next one, the selected programs deleted from the list. The other two push buttons are in reserve. The current program is selected and displayed in the coded portion. Lines of code of the selected program which can be modified. Modifications to the programs must be validated with the Save button. The Program and Active Blocks button allows us to select one visualization or another. In most conditions, the Active Block part is activated when the program is launched. In the next part, we can visualize the status of the axis, the preselected program, the loaded program, and the system diagnostics. Conditions of the axis: override selection, drawing used by the system, kinematics used, preselected program, instance and kinematic state, program loaded. The program will need to be loaded for it to work. The last screen shows us the errors message and system diagnostic. Selection of the PCS program coordinate system or ACE's axis coordinate system. Despite this selection, the system will still seems to use the MCS machine coordinate system plane. The activation buttons located on the right of the screen allow the selection of various options. First, the status indicator appears. This is followed by the start and stop buttons for the kinematics. Loading the preselected program. Start of the loaded program. Push button to stop the program. If you use the program, it restarts from the beginning. Pause in the program. Continue from the point where it is stopped. Error reset. The rest of the buttons are configurable. In the example program, this push button we are used for the simulation of the M functions. For example, the M11 instruction stops the program at that point until the function is reset. In a standard CNC program, this option will be used as a condition control so that the program can follow from the confirmation on certain conditions. M functions. The M functions are used for signal synchronization between the G-code interpreter and the application part of the PLC. A total of 100 M functions are supported. The M functions can be used with reconnection so that they can be reset when necessary. All M functions are available in the CNC program. All codes can be programmed into an NC block. Only global, non-kinematic specific M functions are supported. The behavior is similar to the M functions used in MTX. In the instruction extracted from the application manual, some of the values are outside the allowed margins, 0 to 99, as can be seen in the image. If we place any values outside this range, the following errors appears. The modules used for the status control of the function M, activation and reset functions are as follows and available in two libraries. The first is the CXA motion that uses function modules and is located in these two folders. The second is the CXA PLC Open that uses in this case function blocks and that are located in this folder. Signals used on M11, for example, refer to the identification in the modules using only the numeric indicator, and which will be associated with the module's O input key signal ID. Example of a simple program that will help us to see how to use the M functions. It is important to define the machine program, indicate that the axis must maintain the nomenclatures assigned in the image, so that errors are not generated at the time of program configuration. Therefore, the axis must be used the names in X, Y, Z format. In the first program line, the X, Y, Z axes move to the Z position. The program reaches the line that includes instruction M11 and stops. We can see the status of M11 with the signal ID with the identifier 11 and the current status indicated that this is active. As we have mentioned, this signal will remain active until it is reset. Otherwise, the program will continue to stop. In the example, the M11 button triggers the reset as we can see and reset the signal so that the program can continue. The next move is executed. At this point, we activate what will be the in3 although in this case. We use the number and a set signal activation block to activate the signal. We can see that this is activated in the PLC program with the help of these instructions. M11 is then reactivated and deactivated exactly as described above. A new move is executed, and finally we reset the signal of the in3 function, which as can we see has been deactivated on the PLC part. Using the ML get signal module. With this module, we can control the status of the M functions or control signals that we want to use in the program. To do this, and in order to identify them more efficiently, we must generate a variable of type ML get signal data, associated in this case with the variable in3, and another variable that shows us the status of the reading, and the assignment level. And as we can see here, we will first need the number of the signal used to assign to the structure. Then call the main function module by assigning the previously created variable, and then extracting the signal state with the M3 out is signaled output. The function blocks also allows us to obtain the status of the signal, reset it and activate it. As you can see, the variable is not used as M11 but with the numeric indicator in the signal ID entry. This is true for all three control modules. The last module that generates activation of the M function or the activated signal number. Although it is better that we use the M function nomenclature in order to not get involved in can be useful it. For example, we are interested in controlling the CNC program from a signal coming from the PLC, and we can use in this case the signal, the wait for signal instruction. G-codes. Listing of G-codes. INSI function with high-level language syntax. List of high-level instructions. Thanks for your attention.